Welcome back everyone. So far we have completed developing all the features of this web application. Now we will deploy our project to Docker. In other words, we will Dockerize the project. So let's get started. I will not show you how to install and configure Docker in this tutorial. You will get all the references for installing and configuring Docker from the official Docker website. Nowadays, developers usually install Docker Desktop for development. It is very easy to install and configure on the development machine. Now Docker Desktop supports almost all operating systems. So just download and install. So let's get back to our main task. I made one thing clear at the very beginning of this tutorial series, that is, Django is an ORM-based framework, so it works very easily with any database. So, at this stage, we will use a PostgreSQL database instead of a mysql database, and in this case, we will not install the PostgreSQL server on our development machine, but will use a Docker image. So since we will be using PostgreSQL database, we need to install DB connection driver called scop2 binary. So type pip install scop2 binary. Then hit enter. It may take a while to install, although it depends somewhat on your internet speed. Great, our desired library installation has been completed. So let's first create a file called Dockerfile in our project root directory. The first thing we need to do here is to define the Python Docker image in the Docker file. So type from space. Then type Python. In this case, we need to specify the version. Here I am specifying Python version 3.12. Because I developed this project on Python version 3.12. Here you can see I am checking the Python version, which is version 3.12. Now let's specify our working directory. I am maintaining comments on each line so that it will be easier for you to understand later. So type workdir. Then type /app. Here I have defined a working directory called app. Now we will copy the requirements.txt file. I am maintaining the comments so that you can understand later. So type copy. And here we will define the relative path of the requirements.txt file as the source. Right-click on the requirements.txt file and copy the relative path. And paste the path here. And as the destination we will put our current working directory. So just put a dot, which actually means our current working directory. So the summary is, I copied the requirements file and placed it in our working directory. Now we have a small task left. Since we will be using PostgreSQL database and we already installed a driver library for it, we need to include that library in our requirements.txt file, right? If you look at the requirements.txt file, you will see that the library named scop2 is not present in this list. Let's generate the requirements.txt file again. To generate it, go to the console and type pip freeze, then put the greater than sign, then write requirements.txt and hit enter. Here you see that the scop2 binary library has been added to this list. Great. Now our requirements file is complete with all the necessary libraries used in our project. Now the statement we need to put in this Docker file is to install all the libraries used in our project into the Docker container. So at this point, let's write the command we wrote to install the libraries from the requirements file. So, type run pip install, no cache, dir, then type -r space requirements.txt. Now, we need to copy all the project file to our working directory. So, type copy and put dot as the current source of our project and again put dot as the destination location, that means the working directory. Now we need to expose a port on which our project will run. In this case, we want to use port 8181. You can use any other port if you want. Now, we need to run the command to run our Django project. So, type cmd. And inside the square brackets, write python manage.py run server with quotation marks. Note that I am using quotation marks separately for each word with comma. I could have used run instead of cmd here, in which case I wouldn't have needed to use quotation marks separately for each word. This is actually a personal preference. Here I'm specify the host, which is refer as localhost. And put the clone and write the port number as 8181. Okay, our Docker file is complete. Now we need to create a file called dockercompose.yml, which is actually a driver file for Docker to build and run our project. First of all, let's define services. Under this services, let's create a service called DB, which is for our PostgreSQL database server. Now let's create another service as like DB service. But this service is for our web application. So, we call this service web. Now, let's define the PostgreSQL Server Docker image and all its configurations such as database name, database user, and database password inside the DB service, which are part of the configuration. Here I am using PostgreSQL Server version 13. You can use the latest version if you want. Under this environment property, you will define the database name, database username, and database password. Since I am making this tutorial for beginners to mid-level developers, I am trying to keep it as simple as possible. This Docker Compose file can be configured in a more advanced way, which will make our application much more secure. I will show this advanced level configuration in another tutorial. So stay connected with me so that you don't miss new tutorials. So, here I am define all the database configuration properties as I described earlier. Now, I am defining the volume, where all this database configuration and all other related files and data will be stored. Here I name this volume as Postgres_data. And I am specifying the path of this volume. In this case, if you know some basics of Linux, it will be easy to understand the path that I am defining here. But I hope you already have an idea about this path. Now, let's move on to web services. First we need to build our project. This command initiates the process of building a Docker image. Here represents the current directory. It tells Docker to use the current directory as the build context, meaning that all files and subdirectories within the current directory are available for the Docker build process. And after that I am executing a command to run our Django project. And you already know this command. And here we are also defining a volume. In this case we are referring to the working directory, which is /app as the volume, which we previously defined in the Docker file. Now defining the post where forwarding port will be 8181. Here we have to do one important thing, that is since our web service depends on DB service, we have to use depends on property where we will refer to DB service. This means that DB service has to run first and then web service will run. Now we will define a common volume for all these services so that all the configuration and related files of the services we define in this file are stored in this volume. In this case, I am referring to the volume I defined as Postgres data. You can define another volume directory if you want. Now we have another very important task left. Since we are now using a PostgreSQL database, we need to change the database connection configuration in our settings.py file. First of all we have to change name of database engine. Here I am writing PostgreSQL instead of MySQL. Now let's look at the Docker Compose file to see the database name and database credentials that we defined for our database, which we will use as database credentials in our settings.py file. So I'm writing the database name and its credentials here. I am saying again that these configurations can be made more secure. Since this is a tutorial for beginners and mid-level developers, I am trying to present it in a simple way. Stay connected with me so that you can get new tutorials as soon as I upload them. Here, this is very important. In the hostname section you have to define the name of database service we define in the Docker Compose file. Here database service name is DB, so in host section you have to put DB, not localhost. And as we all know the PostgreSQL database default port is 5432. So, write 5432. Oops! I made a small mistake here. The Docker file and dockercompose.yml files needed to be placed in the root directory of our project where the manage.py and requirements.txt files are located. So, let's drag Docker Compose and Dockerfile and drop those to the project root directory which is CRM directory, where manage.py and requirements.txt file is located. Okay, now we need to build our project. To do that go to the terminal and type Docker Compose build and hit enter. Oh, we get an error. The error is basically requirements file related. Requirements file cannot be copied. Let's fix the error. Here you see that the relative path is not correct to read the requirements file. I need to remove the CRM text here, because the Docker Compose file is now in the root directory of the project. Oh, we need to make a few updates to our requirements file before building. Here you see the MySQL-related library list present in this requirements file. And since we will not be using MySQL database, we will comment out these libraries, so that these libraries are not installed in our Docker container. Okay, now let's build the project in Docker. So, type docker-compose build. And hit enter. This command will install required dependencies and libraries. Before running this build command, make sure that Docker Engine is running on your development PC. Okay, great, our project has been successfully built in Docker. Since the Docker build has completed successfully, now let's run our project in Docker. So, type docker-compose up and hit enter. Here you see the DB service has started. And also the web service has started. For now, we need to terminate the services a bit. Let's check the port of the web service. It should run on port 8181. To terminate, press Ctrl+C. Okay. Our both service is terminated. Now let's check the port for the web service. You see here I have written 8000, but we wanted to run on port 8181, right? So change it to 8181. I hope everything is okay now. Now let's build the project again. Building started. Nice. The project build completed successfully. So now let's run our project in Docker. To run our project in Docker, type docker-compose up and then hit enter. Okay, great. Our DB service and web service both is up and running. Let's check the Docker desktop. Here you can see that our DB service and web service both are up and running, where the web service is running in port 8181. Great. Wow. Great, finally we succeeded. Our project is now running on Docker. And notice in the URL that the project is running on port 8181. So finally we were able to Dockerize the project. But there are still some tasks left, like creating our database tables, then our project will be fully functional. So, now I am going to terminate all services. Now we need to run migrate command in our Docker container to create all tables in the PostgreSQL database. So, to run migrate command in Docker container, type docker-compose exec, then write the service name, that is web, then type the migrate command, that is python manage.py migrate. And hit enter. Oh, I've terminated all the services. Let's run the services. We already know how to run the Docker services, right? Okay, our all services are running now. Let's open another terminal. We will run the migrate command in that terminal. Now run migrate command. So, type docker-compose exec, then write the service name, that is web, then type the migrate command, that is python manage.py migrate. And hit enter. Hopefully the migrate command will execute successfully. Wow! Great! Our migrate command completed successfully. Here you see all the tables we need have been created. So our migration is complete. Now we need to create a super admin user. Otherwise, how will we access the Django admin panel, right? So let's create a super admin user. So like the migrate command, type docker-compose exec and type the service name web and then type create super user. Then hit enter. Here I am writing pguser as the admin user. I am putting pguser@email.com as the email. Now enter the password. I am retyping the password again. Because I put short password, that's why it shows this warning. Just type Y and hit enter. Great, we have successfully created our super admin user. Now let's check if everything is functioning properly. Here I am trying to log in with the username and password of the super user I just created. Wow! Great! We were able to log in successfully. And all the features we developed are showing here. Nice! Let's create a new client, so that we can make sure our system is working properly. I mean, whether data is being inserted into our new database or not. So let's fill out this form. Okay, I'm almost done filling out my form. Now click the Save button to store in our new database. Great! We have successfully stored data in our new database. Now, let's check the Django admin panel. Click on the link named Clients. You see here, the data for the client you just created is showing here. Great. Everything is working fine. So I hope you now understand how robust the Django framework is. It can adapt very well to any database. Now let's configure pgadmin in our Docker container. As you may know, pgadmin is basically a client service for managing PostgreSQL database servers. So let's first terminate all the services in our Docker container. Now let's go to the dockercompose.yml file and create a new service called pgadmin. Now here I define the Docker image of pgadmin. So, type image clone dpage/pgadmin. Now, define environment for the pgadmin. Here we will write credentials for the pgadmin. First of all, let's define the email address for the pgadmin. Using this email, we will need it as the login credentials to enter the pgadmin panel. Here I am writing pgadmin@admin.com as the default email. Now I define the default password for the above email. Here I am entering pgadmin as the password. Now let's define the port. pgadmin will run through this port. Here I am putting 5050 as port, which will forward 80 port. Since pgadmin is dependent on the database, which means the database server will run first and then the pgadmin service will run, right? So let's define that depends on property and put db service here. Okay, now let's run our Docker container. Oops, what did I do wrong? Let's check Docker Compose file. Yes, I think I found the problem. Let's solve it. See here that our web service is actually inside the services of the Docker Compose file. So our pgadmin service also has to be inside the services, right? So, if we just fix the alignment, hopefully our problem will be solved. Now look, all three of our services are inside the services. Here, I am using port 8080 for the pgadmin service here, whose forward port is 80. And for the web service I'm using 8181 port. Now let's build our Docker container. So type docker compose build and then hit enter to build. This time it may take a little longer to build. Nice. The build completed successfully. Now let's up and run our Docker container. So to up and run the Docker container, type docker compose up and then hit enter. Now it may take a while for the Docker container to get up and running because the container is now pulling the pgadmin image from the Docker repository. So be patient. The image pooling of pgadmin is almost complete. It looks like it might take a few more seconds. Here you see, the pgadmin image pull is complete. Now you see it being extracted into our Docker container. So be patient. And I hope it will take a little longer. Here you see, the extraction has been completed successfully and the services we defined in Docker are waking up. Look, our DB service is already started. Now the pgadmin service is starting. This will also take some time because it is now configuring itself according to the credentials we defined in the Docker Compose file. In the meantime, notice that our web service is also running. Since we did not define pgadmin service as a dependency on web service, so pgadmin service is not dependent on whether it is running or not. Web service is only dependent on DB service running, so web service is run only after DB service is run. I hope this is clear to all of you. Here you will notice that the pgadmin service is running, but we are not able to access it yet because its configuration is still in progress. If you look at the Docker desktop, you will see that the pgadmin service is running, but as I said earlier, its configuration is still in progress. So be patient for a while. Yes, I hope pgadmin is fully running now. Now let's check. Hopefully everything will function properly now. Yes, pgadmin is loading. Now it seems that pgadmin will start working properly. Now let's take a look at the Docker Compose file and see what the login credentials of pgadmin were. Let's copy the email address and its password. I have mentioned before that this Docker Compose file could have been made more secure, but since this tutorial series is focused on beginners to mid-level developers, I am not covering that complex part here. I will share that complex configuration with you in another tutorial. Now let's hit the login button. Great. We were able to successfully log in to the pgadmin panel. Nice. Now let's connect our pgadmin to the PostgreSQL database by clicking on the link named Add New Server. From the DB service defined in Docker Compose file, let's copy the database server access credentials. Here in the Connection tab, put the database access credential and hit the Save button. Nice. We have successfully connected with our PostgreSQL database. Here, if we expand the database's tree menu from the left panel, you can see our database. Now expand the schemas. You can see tables. One thing I would like to share that is, actually PostgreSQL database is very similar to the Oracle database, which means its structure and features are quite similar to Oracle database. Now let's check the client table and see if the new client data we inserted a while ago is there or not. You see the new client data we inserted is showing here. So now we're sure that all of our configuration is working properly. So, you see how robustly the Django framework can adapt to any database. That's really cool. So, let's store another client in the database. Hopefully everything will work fine. In this case, I am putting my own name and my details in this client form. I have almost filled out the form. Now hit the Save button to store this data to the database. Great. Our new client named Tanvir is stored in the database. And it shows in this list view. Now, click the Execute button, which looks like a play button, and see its output. Look, here we see a newly created client named Tanvir. Now let's check from the Django admin panel whether all the data is showing properly or not. Hopefully everything is working properly. Yes, all data is showing here as well. Nice. Okay, we have come to the end of this tutorial. I hope you are enjoying this tutorial series. I am uploading the entire project to GitHub and the GitHub link is given in the description box. If you want, you can use my entire codebase in any of your own projects. So, stay connected with me, because there are many more real-life project tutorials coming up on machine learning, AI and deep learning, data analysis and data engineering. See you in the next tutorial, which is going to be more interesting.